Today we're going to be looking at a continuation of Unit 7, Learning Target 5, if I can prove theorems about triangles. We're going to be looking at the midpoint and distance theorems, or more closely just what are midpoints and how do we find a distance between points. This is a prerequisite that's going to come in handy on Tuesday when we learn about mid-segments. So the distance formula is used to compute any non-vertical, non-horizontal length. So basically any diagonal length between 2 points. And it's going to be derived, or it is derived, from the Pythagorean theorem. So if you think back to your 8th grade summer class, where we learned about the Pythagorean theorem, this is a derivative of that. So example 1, we're going to plot the points and use the Pythagorean theorem to find the distance between points A and C. So point A is at -2, -2, right there. And point C is at 3, 5, so right there. And we are interested in the distance between those two. Now, unfortunately, there is no easy way out of just counting diagonal boxes. That does not work here. So we're going to use the Pythagorean theorem, and if you remember, Pythagorean theorem works with the right triangles. So we need to create a right triangle. So I'm going to draw a vertical distance down. And then I'm going to draw a horizontal line to form a right triangle. And we can see that that's a right triangle right there because your two lines are intersecting, they're perpendicular to each other. So if I'm using the Pythagorean theorem, I'm going to, remind myself that the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So I'm going to find the distance of my two legs. So I'll label this new point that I created here, we'll label that B. So for CB, it's 1, 2, 3, 4, 5, 6, 7 units long. So one of the legs of my triangle is 7, so I'm going to square that. And then the other leg, 1, 2, 3, 4, 5, the other leg is 5 units long, and I will square that, and that is going to give me the length of AC. So 7 squared is 49, plus 5 squared is 25, and that's going to give me my hypotenuse squared. And 49 plus 25 is equal to 74, equals C squared. And so to find just the value of C, or the value of the hypotenuse, remember that I do need to then take the square root of both sides, which would give me C is equal to, we'll say, approximately 8.6. So the distance between AC is 8.6. And again, that's approximately. I should be using my approximately symbols. Okay, so if we're going to be using the distance formula takes all of that and lumps it together. So for the distance formula, I'm going to be working backwards. So the last step that I did to complete my previous problem was taking the square root. So I know I'm going to be looking for that hypotenuse, and the last thing I did was take the square root. Okay, right before that, I squared, so I had the square of the length of one of the legs, which is really the difference of our x's or our y's. So I'm going to say that it would be x1 minus x2, and again, that's squared. And then we added it to the length of the second leg, which would be y1 minus y2 squared. And so that's going to be our distance. And maybe I should even make this C D for distance. Okay? So if I use the values that I've been given, so A, I'm going to rewrite them here. A was at -2, -2, and C was at 3, 5. So if I take my x values, I have -2 and 3. So it does not matter which is x1 and which is x2. It will work out the same regardless of which one you choose first. So I'm going to do -2, take away 3, and whatever that is going to be squared. And then my y's, I have -2, take away 5, and then I'm going to be squaring that. And then take the square root of all of that. So I can simplify from here. So -2 take away 3 is -5 squared. And then I'm going to add that to -2 take away 5 is -7 squared. And then if I simplify even further, -5 squared is 25. And -7 squared is 49. And you'll notice that our numbers are starting to look familiar. The square root of 25 plus 49 gives me the square root of 74, which then gives me the approximate value of 8.6. So you can see that either way, we're looking at the differences of our x, whether we draw it out, which we did up in the first part of that example, or if we use the formula. If you understand where the formula comes from, you don't really have to worry about memorizing it, because you can always fall back on the Pythagorean theorem and drawing out a right triangle to help you out. So looking at example 2, find the distance between -1, 3 and 5, 2. So again, if I'm looking for the distance, and I recall when I was in school, when I was taught this, my teacher made a comment that it looked like a face. So you have an eye there, and then a nose, and then another eye, and you can, I don't know, I guess think of your squares as eyebrow rings or something like that. And then you can fill in your values. And it really doesn't matter we put the x's first and the y's second. It is not going to change your problem if you took the difference of the y's and put that first, or the difference of the x's and put those second. It's just traditionally we put the x's first. So I'm going to take 5 minus -1. That's just a choice that I chose the second ordered pair first. And then for my y's, I would do 2 minus 3. So if I simplify that, 5 minus -1 is 6. So that'd be 6 squared plus, and then 2 minus 3 is -1, and -1 squared. And simplify even further, 6 squared is 36, plus -1 squared, -1 times -1 is +1, and that would give us the square root of 37, which if we were to do that in the calculator, square root of 37 would be approximately 6.1. Okay, I want you to go ahead and try to find letter B on your own. Pause the video and then check your work when we come back together. Okay, pause your video now. Okay, so looking at your work, go ahead and compare. You should have gotten an approximate answer of 5.4 and an exact answer of square root 29. You will learn next year how to simplify radicals, or maybe even towards the end of the year we'll practice that a little bit. But for right now, you can leave it as either the square root of 29 or estimate it or round it to approximately 5.4. Okay, moving on, we're going to look at the midpoint formula. And so the midpoint formula is used to locate the midpoint of a line segment. Go figure. Okay, and it is derived from the averaging process. So we know averaging, you add up the values that you have and you divide by the amount of numbers that you were adding in the first place. That's the averaging process. So looking at example 3, it says find the midpoint of CD. So C is located at 6, -4, and the D is at 12, -2. Oh my goodness, and my graph does not go to 12. How horrible is that? So we're just going to have to improvise. So let's get rid of C, and I'm going to adjust my values to 2. So 2, 4, 6, 8, 10, 12, -2, -4, -6, -8, -10, -12, and 2, 4, 6, 8, 10, 12, and -2, -4, -6, -8, -10, and -12. Alright, so let's plot this point. So C is at 6, -4, so we'll put C there, and then D is at 12, -2, which is right there. So it doesn't change our problem too much. And we want to find what is the midpoint of line segment CD. So to calculate your midpoint, you're going to take your x values, so x1 plus x2, and you're going to divide it by 2. That's going to give you the coordinate for your x value in your midpoint. And then you're going to take your y values, y1 plus y2, and divide it by 2 to get your value of your y value in your midpoint. So if I'm looking at my x values, I have 6 and 12. Well, 6 plus 12 is 18. 18 divided by 2 is equal to 9. So my x value in my midpoint is going to be 9. And then if I take my y values, which is -4 and -2, if I add those together, I get -6, and divide by 2. -6 divided by 2 is -3. So my midpoint of CD is going to be at 9, -3, which would be right there. And that would be my midpoint. Go ahead and try example B on your own, following what we did in example A, and then we will check your work together. So pause your video right now. Okay, so go ahead and check your work with mine. If you went through everything correctly, you should have gotten your midpoint at 1.53. If you didn't, go back and kind of check to see if your work does not match mine. Alright, going on to the last example, sometimes you will be given the midpoint in one ordered pair and you'll need to find the other endpoint of the segment. So for example 4, it says find the coordinate of B if the coordinates of A are 5, -4, and the midpoint of AB is 3, -2. So let's first start by plotting the points that we do have. So A is at 5, -4, which would put that right here. And then the midpoint of AB is at 3, -2. So that's our midpoint. So we're going to begin this process by working backwards. I do think some of you might be able to just do this in your head, but we're going to talk through and show our work initially until you have a pretty good handle on it. So we know that to get the x value of my midpoint, I need to take my two x values and add them together and then divide by 2. So if I want to unbuild that equation, I'm going to work backwards, just as I would to solve for x. So the last step that I did was to divide by 2. So if I multiply both sides by 2, that gives me 5 plus x equals 6. And then if I go ahead and subtract 5 from both sides, I get that x is equal to 1. So I know that the x value in my ordered pair for B is going to be 1. Then, to find my y value, I know that I would need to take the y value that I have, add it to another y value, divide by 2, and that will give me the y value in my midpoint. So just as I did with the x value, I'm going to multiply both sides by 2, and that gives me -4 plus y equals -2. And then I will add 4 to both sides. Oh, just kidding. Go ahead. -2 times 2 is -4. Oh, goodness. -4. So I'm going to go ahead and add 4 to both sides, and I get that y is equal to 0. So the ordered pair for B is going to be at 1, 0. And I can see that that makes M my midpoint, and I was able to find the value of my missing endpoint. Alright, you have practice on Delta Math, so go ahead and log into that and complete those problems. Make sure you complete all 12 problems so that you can earn all credit for getting it done. If you have any questions, log into office hours from 12:30 to 1:30 or send me an email. Good luck! Bye!